global cybersecurity company and identity platform. Today, I will discuss a little more about how to build your private cloud framework for phishing email filtering. So, even though we talk about private cloud framework, it will be built on GCP as a public cloud provider, and we're going to go into details a little bit about what is phishing, about how the framework, what's the requirements, design, and implementation as well. As probably everyone, mostly likely everyone is aware, phishing is an extraordinary event where it's sort of like a subset of spam, where the attacker, it depends. Like there's a couple of phishing attacks. Attacks maybe will be the attacker going after your contact details, such as email, or he just like try to gain access to the corporate environment. Then we're going to discuss about the framework in general. So we're going to see what's the framework requirements, what we think that should be the framework requirements, the framework design, implementation. So first things first, I'm going to start with the phishing. So like we mentioned, there's like a lot of online fraud techniques and methods for acquiring sensitive personal data. Those techniques and methods is trying to get logins and passwords or any other sensitive personal data by sending, in most of the cases, sending an email. So it can be a couple of things. For example, like sending an email asking to reply with a couple of your details and mentioning that you have won some prizes. And then there is another process of obtaining that information by providing a well-known URL or a page. So that well-known URL can be, let's say, a gmail.com website, but it will not be a gmail.com, it will be something else, but it will be, the design will be represented as a gmail.com. Another thing can be hotmail.com or anything like that, where you will, or any other known corporate login page, which is kind of like a more attack where it's going to ask for details. So there is a couple of other things as well. It can be a step-by-step attack, which means that they can send an email with an attachment. That attachment can be a malicious file, where it will be on the first time a PDF, sort of like and then downloading it, it can be execute that file and gain access to your corporate environment. Most of the attacks can be for malicious purposes, but there is many of them where they just looking forward just to obtain some money or anything like that. And the way we identify these phishing emails is that there must be a relationship between the phishing and something inside. So for us to get those details and for us to think about how we will build our phishing framework, we need to think about the phishing as an extraordinary event where there can be a connection between the phishing and the urgency. So for example, you can get an email and that email can be, okay, you have won 10,000 euros and you have 5 minutes to respond with these details. So by providing that urgency, they are actually giving you very little time for you to be able to think about whether this is authentic or not and just provide those details. Another thing is authority. Authority can be your line manager or your second line manager or any from the executive, for example, committee, any chief technical officer. So they will be kind of impersonating that person by sending you an email and asking you for a couple of things within the corporate environment that you should share with them or provide them access to some, let's say, like on-premise device or anything like that. Another thing that they do have is a very long URL. So what they're trying to do is they try to mask that thing where there you should, what you're going to open is going to be a very long URL, and on a first point it will sound or it will look like legitimate, but it will be a phishing attack or a phishing impersonating website in the back. They also, there is a couple of them that there are can provide an incredible deals, and also a financial information request. So this financial information request can be like a very known that I have encountered. It's that they try to combine the, for example, the authority, they will be impersonating an executive person, and they will send an email to most likely the human resources or the payroll or the finance department, or they will say that they have changed their bank details, and if they can update their bank details in the system, so the next time they will receive their salary, then that salary will be sent over there. So this is something that's is raising, especially recently during COVID. So there has been a lot of attempts to be this. I have tried to go into that water just to get kind of like testing for the framework, but yeah, a little advice from my side is never use your personal one. And if you would like to test or anything like that, always create a new email that you will use solely for that purposes, and always open those emails when you're in a sandbox environment. So we're going to start now for the framework. Framework requirements, they can be, well, in general, we think about the framework requirements, we can think about two framework requirements. That one can be functional, and the other one can be non-functional requirements. So the functional requirements are the ones that they have the technical requirements, where we will be able to monitor, for example, for new emails within the user mailbox. This is very important to monitor for the new email. And the importance here is that by monitoring for the new email, we will be able to kick off that scan of the email once that new email will be received into the inbox. Another thing is that we need to label. So this is specifically for my use case, where I will be using a Gmail. So Gmail has a very nice handy labels, where we should be labeled the newly receiving email. Why do we need to label? Because we will need to inform the end user that that email has not yet been scanned. It is in the process of scanning, and we will need a little time before that one will finish. So the user still should be extra cautious while opening it. The next one is that we need to extract the email content. This can be many details within that, whatever we want to look for, and then we should predict if the email is safe. If the email is safe, we should provide a feedback where we will be informing the end user that that email is safe, for example, by labeling that is safe, and go ahead and open it. We can inform also the end user if we are 100%, or let's say like in the 99% percentile sure that that email is phishing. We can, all these a little kind of like, I would say, dangerous in those things. If we do, we can straight away just remove it. Just remove it, move it to the bin, the email. But another thing that we can do is that we can label it and be like, okay, this email is unsecure. So us, as a framework, we recommend the end user to be cautious while opening that email, just because we have found a couple of things that it's pointing to the phishing, and just always be cautious when opening that. Another thing what we have is the non-functional requirements. So whenever we published a product, for example, um, the user will need to be able to register for the framework by following the instructions. So that non-functional requirements is that the instructions, they need to be very clear. So the user will need to be able to follow step by step, be very clear what they need to do in order for them to be able to set up their mailbox under the framework. In our case, it will be deployed on a Google Cloud platform, and the user should provide access to their email account within a web browser. So this is just a general application that is going to be registered. So whenever we do, you've probably seen it, whenever you want to sign in with Google somewhere, and your Google email, you click open a link, and over there you will be presented with sort of bullet points, where the application provider will be able to tell you what they will need access to. So for example, they will need access to your monitor, to your mailbox, to your contacts. They will need to be, for example, on your behalf, something like that. And we need to clearly state what access we will need for this. This is very important to be transparent, just because if we do not set what the clear access we need, and then something happen, it can be very, very negative in the future. And the initial email labeling should take less than 2 seconds. So this is just a general thing, and it is actually quite good to be less than 2 seconds, just because when the user receives an email, it is pops in an inbox, and they are already into the inbox, or they have it open onto the web browser. We need to be able to label that, just because they will not click on that link before we were going to tell them that it's pending. And in the best scenario, it should take no longer than 10 seconds to provide an outcome. So less than 2 seconds, we label that email, we extract all the details, we do what we need to do for that, and the outcome should be less than 10 seconds, where we'll be able to label that email, whether it's been phishing or whether it's being not phishing, or in that case, legitimate, so to say. So that is in general what we have about the requirements that we need to have. So this is just a general requirements. It's based on what I have researched and what I believe it will be important to be for the scope to be covered for that. And right, so we're going to talk about the architecture of the framework. So the framework is actually using three. Here we have the Gmail API, but it's not it is not product that is available under the Google Cloud Platform, although it's product from Google. So the architecture what we have is a Gmail API, a pops up as a publisher and subscriber, Cloud Functions, and Cloud ML, or in our case, we will be using AutoML. So all of these are, each component, so to say, provides a unique function, which is critical for the framework. So the Gmail API is used for getting that access to the user mailbox and for the monitoring of a new email. So the Gmail API has a very, very handy I would say, like kind of a function or anything from the API, where it will monitor for a new email, and once a new email will be received into the mailbox, it will send, it will subscribe, it will send to our pops up topic that we will be able, so it will publish over there, because it's already into the setup. We will be using Cloud Functions for doing that process, and we'll be able to subscribe Gmail API. So this is very important, because if we have a framework where we don't utilize this and we do not take advantage of this, then we would need to check constantly about whether a new email has been received. Checking constantly about a new email, whether it has been received, it can be very, very expensive. So that's why it's very good. Pops up, just publish a subscriber component. So this will be between the Gmail API and the Cloud Functions. So a new email is received, publish an event to that topic. That topic will then kick off a Cloud Function, and then between them, they will be able to do the, so to say, step by step within the framework. AutoML we will be using just because we will need to, once we will extract that data from the, let's say, the email body, what is going to be that one. So remember before we have discussed about having kind of like urgency into the emails, or impersonating, or anything like that. So whenever we have urgency or anything like that, most of the time the phishing emails, they follow a structure. So that structure, by having our own AutoML model and creating that structure will be very, very good, so that we will be able to utilize that AutoML model and get our probability whether or not that or email body is phishing. So this is where it comes quite handy. The business process model is kind of like this. So what we have over here is that on the top left, we have the Gmail API, right? So that is the one that is going to subscribe to PubSub, but also it will publish whenever a new email will receive. A PubSub will then kick off a cloud function, and then cloud function, we're gonna have we're gonna talk with the Gmail API because we extract that data, we'll send something to HTML, then it's gonna send some outcome from that one to another pops up, and sort of and so forth. So as you can see, there is gonna be a lot of details. I did not label them on purpose, just because I would like to go into details for every step, and then at the end, we're gonna come back to this slide, and I hope then it will be much clear about what we have and how is the step for us to provide that feedback. So that is when it comes to time for the framework implementation. So as we mentioned in the beginning, we're going to have the AutoML. So AutoML, we're going to use the natural language models. So over here, we're going to do a single classification. So for this, I have used two public available data sets, and I will be creating two AutoML models. Why? Just because by having extracting that data, there is a lot of components taken into the consideration, right? So first thing first, when we receive an email, it is the sender. So that sender have a domain, and once extracting that domain, we can utilize the URL of that model to check if that domain is actually legitimate or is actually phishing, right? We then have email subject, for example. We then have the email body, the structure of the email body, the links within the email body, and maybe let's say attachment as well. As you can see, we have the two data sets. They have a very big difference between them. The URL, the data set that I have found, the public available one, and the good one was almost 96,000 URLs, and the ratio between them, once the data was cleaned, it was kind of like 50-50. So both of them around 48,000 legitimate and phishing links. By submitting this to the AutoML and training, it took just, I believe it was just less than 8 hours to be able to do the single model classification. So we will be able to send details to them. The email one is quite different. So we will have only 5,000 messages or emails, so to say, data sets, and then 4.5 by 600 is the ratio. So that one was a good 90 to 10% ratio, which it will not provide that best one, but at least we have something, and we'll be able to get anything from there. So the messages or the emails between the data set were the most known or the most common one. And if anyone does or knows of any other data set that we'll be able to utilize, please do reach out. And I'm more than happy to go through it again and do the training with that. So the URL model, once we receive the result from that training, or 99.58% was precision and 95.09% recall of the model. So to get an idea how ready the model is, it's AutoML uses precision and recall. So a high precision model produces fewer false positives, where a high precision recall model produces fewer false negatives. So both of these ones is very important for us, just because by producing false positive or false negative, we'll be able to provide better outcome or better results within that. The messages model, it actually, you can see, is very high as well. So that's the one that it was only 4,500, but still at the end, based on that 4,500, the AutoML model results were quite good as well. As you can see that the precision was very close, as well as the recall as well. So in the real world, this probably will be much bigger. Like for example, for URLs, there is a public one called Google Safe Framework, which can be utilized, which is also utilized here as well. They have an API as well, but it's a public database from a well-known phishing URLs, and I believe it's in the millions of phishing URLs over there. So let's go for the architecture. And what I'm going to do here is I'm going to just divide it in a couple of things. So for the framework, the requirements that we have, so the functional and the non-functional requirements, within the non-functional requirements over there, we had a non-functional requirements where the user needed to go somewhere on a website, and they will needed to be able to provide access to their Gmail, and then also over there we will need to be able to create those labels as well and anything like that. So what is happening? A user is visiting a website. It grants access to our phishing email framework. So that's the first step. Then what it does is when it grants access to our phishing email framework, um, invoke Gmail API. Gmail API subscribes to the pops up and also kicks off our first cloud function. So the auth init or authorization, like initial authorization over there, is what we will be able to go through there. And so once I execute that cloud function, we will be able to get more details about the user. So which details we are interested in. So just by having that and being able to do the OAuth over here, the authorization, um, the most important thing what we need to get is the user's email address, right? So once we have the user's email address, we have the rest of the things is just going to be authorization as well. So once that one is done, it's going to kick off the callback. Within the callback, over there, what we'll need to do is I have utilized here another product, but it's just very, very small, and it's only for I would say for a very good maintenance. So I have utilized a data store, or if anyone would like, we can use a cloud Firestore as well. So what I do here is that once I get that email ID um, within the callback, I save that email ID. So I do an alias based on that and obfuscate that one, save it into a data store, and over there, I use that one as well to save whether or not that user had before um, had before provided access to our framework. Why is this important? Well, this is important because let's say you have subscribed to our framework and you have used that, but the framework is kind of slow, right? So it's slow for you. Me as a maintainer, I did not maintain it at all. So it's been slow. You checked, for example, it's been the last update, I don't know, maybe a year ago or something, and you're just going to revoke. So you're going to go to your Google account, you're going to revoke access. So that's it, right? So the access has been revoked. However, when you're going to revoke that access, as you can see in the email labels pops up and comes, and cloud function over here is that I am um, creating those functions, right? Uh, so what this means is that I create the labels over there. So I use, in my case, because I have done in Node.js, so I'm creating the labels. So which labels I would need to create? So I would need to create 3 labels in my case. So once, like to satisfy my 2-second rule, once the email is received, so that will be my pending. So let's say you're using traffic lights. So use the yellow for a pending, right? Which means that whenever you're traffic light, means that okay, either get ready or either pass the traffic light with cautious, right? The next thing I have is that secured, which is going to be a green one, and unsecured, which is going to be a red one, which means that okay, unsecured, which means that it's a no-go from my side, and just like in real world, if you will be passing that red traffic light, you will most likely be penalized here as well. If you open that email and that there has been some file that you will download or anything like that, you'll most likely be penalized by exposing or giving access to the attacker within a corporate environment. At the end, I have the email watch. The email watch is that after everything, all the authorization will be done, then it is going to be the Gmail API subscribing to that one. How it looks about creating a label is that we invoke the Gmail users label API endpoint, and is simply just provide a text color, provide a background color, whoever it is, the email ID or anything like that we want to create. The main things that we talked about before with data store is that so we have mentioned that maintain it, and then the next step comes that I have created a 2.0, a new one, and that one is much better. So you would like to get access again, so subscribe again to our framework, and what I will need to do is I will need to check whether or not that labels are available. If the pending, secured, unsecured labels are already available over there, I can see them, compare text color or whatever I would like to have, and they're over there already, which means that I don't need to create them. Because one thing is that if you would like to create those ones with the same name, then Gmail is gonna say like, okay, this is a no-go, and then you have a label that has not been created, and then your framework will fail to do that just because you would like to invoke, get that label ID or whatever, or a label name, or get that label ID based on a label name, and then assign to that email, but it will most likely fail over there. So that is the main thing. The email cloud functions is the core one and interesting one, where the whole sort of resonate comes. So Gmail API. So we have the first one is the email watch. The email watch is just my labeling over there. What it does is that once a new email receives, it publishes an event to the email watch topic, which then invokes the cloud function. So Gmail sends a notification. We execute the new email watch cloud function. Email new watch cloud function have a couple of methods that goes through. For example, it's check data, do this, do that, checks a couple of things over there. What it does over there, we send it to email domain, send it to email links, email body, email outcome, right? So all of these between them, they have the subscribe and publisher. We're using PubSub just because I would need to get an outcome from every cloud function, but I would need to be able to pass that outcome to the next cloud function. Just because the cloud functions being a serverless, they do retain, it depends. So they do retain, if you have like a couple of variables, they do retain the variable scope over there, but it depends how long they will be over there. So just to be safe and just to be, well, better practice as well, is that I would need to pass those data to PubSub, and via PubSub, invoke cloud function, send it over there, then buffer data, and extract that buffer data, and whatever I need to do within that. So first things first, we have the new email watch cloud function. So a couple of things over here is that once we're going to receive that event to the PubSub, PubSub will invoke and will say that, hey, this user is saying to me that there is a new email. So what do we need to do? Sends it to the cloud function invokes cloud function. So what do we need to do? First things first is that we need to get that most recent message with a tag, right? So we get a tag from PubSub, we get that most recent message with a tag, and then what we need to do, we need to extract the info from that message. So extracting the info is something that, for example, in our case, what we have is that we're gonna get the email domain. We will get the not the email domain. We will get the sender. So we will get in the sender, right? So we get in the sender. We will get the email body, and we will get the email attachment. That's it. We're just gonna get them. If the attachment is gonna be a yes or no, we're gonna get the body in the text, and we're gonna get the center in the text as well. So we get that, we label it straight away. Boom. We say that over there, okay, this email is appending, right? If there is an attachment, so we check over there if there's an attachment, if there is a PDF attachment, right? If there is a document attachment, if there is a TXT, a text document attachment, and a very, very handy feature, what we can do from the AutoML is that we will be able to extract the attachment from the message, and then we will be able to predict that attachment classification. So if there is let's say a text document, we'll get all the text within that text document, and we will be able to send that to the AutoML and predict attachment classification. We will get the probability between 0 and 1, and depends on our threshold that we have assigned, we will be able to use that probability from that attachment at the end, where we will be having the email outcome. So getting that one, get it like, for example, 0.9 from the AutoML would mean that I am 90% confident that that email attachment is phishing or is malicious, so to say. So if there is over there, we're gonna get that, and then we will publish that message to the email domain pops up, or to the email domain topic between pops up. And if there is no attachment, simply with all those details that we have, we will just publish that message again. So there's going to be two things over here. We will include the total outcome of the classification as well, or if there is not, we will include a 0, right? We include a 0. There's going to be no changes at all. We didn't send anything, or we don't even need to include anything. So once we will publish that message to the email domain, what we then do over there is that we will get whatever we have, right? So we're gonna get, okay, so the previous one had attachment, we have 0.9 so far. Okay, perfect. We're gonna get the domain from the sender, and then we're gonna predict phishing classification for that domain. So what it does, this one, is that once we will send it to that one, the AutoML will be able to say whether or not I think that this one it is, based on whether or not we have that one over there, right? But this can be tricky, right? Because that domain can be gmail.com, right? Because some attacker created a gmail.com an email account, and then they use that one just to send malicious emails across the users. So what we're going to do is that we're going to be able to utilize the Google Safe Framework API as well. So as we mentioned before, Google Safe Framework has millions of URLs, and we'll be able to utilize that one and see if there is anything. Why is this important? Well, our natural language model is not perfect, right? So we just created one, and it's still new, and it needs more and more data, right? So we say that it's not a phishing. We send it to the Google Safe Framework. Google Safe Framework comes back and says, okay, I have this one here in my database. So it has been used for phishing. So definitely this domain is a phishing. So what do we need to do here? Well, we need to get that phishing domain, right? We need to send that, and then we will need to send it to the AutoML model, and then we need to train that AutoML model again. However, this can be very expensive. Can you think about, it took us almost 8 hours to train that model, and then we received an email, boom, okay, we train it, all right, cool. So what we can do here is that we will be able to send it somewhere, save it, store it somewhere, and then we'll be able to add it over there and retrain our model once a week, once a month, once a day. If you would like to do that, that can be well, not expensive that much, but more expensive than once a week. And this is what we're going to utilize the Google Safe Browsing API. The next thing we have is extract URLs from text. This is the email body that we received. We're going to check if there is a URLs within the email body, and we're going to extract them. And depending on that one, we will be able to publish, right, that message. So we will publish that message to the email links pops up, or email body. So this is only depends if we do have a URL. So we're gonna invoke another cloud function just for the links, or if not, we're just gonna go separate. If we do have an email links, we're gonna extract those URLs, or just get the data that was extracted from before, and then we're gonna predict classification. But what we also need to do is that if there is a multiple emails, we'll still need to scan. So we still need to scan or check one by one to the Google Safe Framework API. So once we check one by one over there, if there is anything that's flagged, the important thing is that if there is anything that's flagged, we will add that result as a 0 and a 1. There is not flagged, 1 means it's flagged. So we will add it to our email outcome, just because if we have 0.7 from our one and then we have 0, so it's going to be 0.7 out of 2. We're going to get to that slide a little shortly. So once that one is done, we have to do email body. Email body, simple. We just predict classification just to check what is it, and we're going to receive from the AutoML model whether or not it believes that this email, that the way that it has been written, it has been phishing. And at the end, we're just going to get the phishing email outcome, right? So that we add that details as we progress on each code function. And once that details is at the end, what we will do is that we'll get that outcome, and then we will be able, based on that outcome, to decide whether or not, right? So there's a 4 category to think about here based on what we have, right? So one category is that we have no attachments and no URLs. One is we have URLs and no attachments, while we have attachments and no URLs, and one we have no URLs within the email body and we have no attachments as well. So if we have no attachments and no URLs, just utilize it one by one over there. The maximum value we can get over there is 3, and we have a 1.9 threshold with a confidence of 0.95, right? So 95% of each AutoML invoke, we need to be confident that this one is phishing. So we will be able to use that and publish it. And if you see over here, we have 0.95, or we have 1.9, but the maximum value is 3, right? Well, even though we have no URLs within our email, we do have a domain, right? So we have a domain from where that email originated. So we will send that domain as well to Google Safe Browsing, and based on 0 or 1, we're going to get. So in our case, for example, the threshold is 1.9. So everything over 1.9, we are confident it is a phishing, right? If it's 2.9, even better, right? Same thing goes to the next one. If you see is 5, but 2.85, and then we have 4 and 6 with a 3.80. So just because at the end, the attachment and the URL, we need to have the email domain, right? We need to have URLs within the link, right? We need to have all of those things that we need to check with the Google Safe Browsing API as well over there. So the 6 comes between the URL but no attachment, it's just because of the attachment. So that adds a 1 over there. So that is kind of what is it for the email outcome. And this is how it looks, for example, within the label emails within the inbox. So if you can see that the pending one, the yellow one, is whatever we once received, we are straight away. And then the other 2 is that this one has been copied. So that's why it says straight away unsecured, just because I have copied from the database and then I have used it to send to one of my other emails just for the test. And straight away, it doesn't matter if I do not originate straight away. So I say this is like a unsecured just because, well, this one is secured, most likely because of the content, or most likely, I'm not sure if the AutoML is just because it says Google. But yeah, so we end up to the results and analysis here. So as we have the 4 categories over there, in between, I believe it was 45 days. Yeah, between 45 days, I have had in total around 300 emails that I have received into my inbox that has been either phishing or it has been not phishing, right? So I have used a separate inbox for the phishing, and I have sent a couple of, well, scheduled as well, sending not phished emails, just because to be able to get whether or not I will get that false positive as well. So whether I get false positive, whether I get false negatives. Unsurprisingly, most of them they had a URL but no attachment, which is the 74.8%, and the other one is a no attachments and no URLs with 22. One and just over 1% is the rest where they had an attachment. So most of the emails received they had no attachment. So there was a 97.3 with no attachment as well. What is it? The ratio between them? The no attachment to no URL, from the 67 that I have received, it was almost 50-50 between a phishing and legitimate. The URLs but no attachment, which is the biggest chunk that it was from the testing, 61% were flagged as phishing and 39% were flagged as legitimate, and the rest was 100 and 100. Well, I have not included here, but there have been just almost 3% false positive from those 61% from the second one, the most one. So the model where I had it predicted that URL it has been phishing, just because so those 3%, 50% from those 3% were emails where they were very long. So for example, there will be a very long emails, and because it was very long and they had a couple of things inside, the model flagged that this has been a phishing email, and the sender or the link or whatever within it has been well, I'm confident that it's phishing. So yeah, that is the most. So the total was 298 emails. So yeah, that is my results and analysis, and kind of the idea and the details of how to create. The framework is not yet published as an open source, just because I have been busy with a couple of other things, just because of life and war neighbor. But what I will do is I will be able to publish it, and then we'll be able to send to any of the organizers, and we'll be able to pass it along if anyone is interested about that. So yeah, that was my talk about how to create a private cloud framework for your phishing email filtering.
Thank you for this presentation, Goran. It was very informative and fascinating.
Thank you.
Let's move on to questions.
Yeah.
Does anyone have a question?
Training dataset. Your training dataset, is it public? Yes, it is public. What I will do is I'm gonna open it and I'm gonna make a note, and I'm gonna get the links. So I'm gonna get the links for the training dataset, and I will send it across into the chat shortly. I will search as well in those one in the meantime. So if there's any question, if you can read out for me, just because I want to get those links as well.
Does anyone have a question? No? Okay. We will put this presentation on YouTube channel. Let's thank Goran again for his presentation. We hope to see you and at on our incoming events.
Yep. Thanks very much for the invite, and hope to see you soon.
Thank you.
Thanks. Bye.
Bye.